Hello and welcome to our Section 2.1 lecture today for our Bridges Math Probability class. Today we're going to jump into an actual introduction to probability and take a look at what probability means, how we can use it, and just start getting a feel for how we're going to look at some things. The first thing that we did in class is we did an experiment. We flipped a coin 100 times. I would urge you to try the same thing. Try to do it yourself, okay? Even if you have to, tell Siri to flip a coin and just keep doing it 100 times, record the result that you get. Now, the weird thing that we had happen in class, which I was looking out for, we wanted to start out by looking at what are the possible outcomes of each event in our experiment. Okay? The event is flipping a coin. The experiment is doing that 100 times. What possible things can happen when you flip a coin? For us, we use the little red and yellow discs that are actually kind of thick. And we said that it was red or yellow. And that's what we anticipated. I'll give you an insight as to something else that happened. And that was sometimes these little coins can land right on their edge, which is kind of weird, but it can happen. It can happen with a coin too, specifically one coin in U.S. Coinage, and that would be a nickel. A nickel is typically flat enough on its edge that it could land there. It's very unlikely. Same with these. I think I figured out that in class it happened twice out of 30,000 flips. Okay, so that's not very likely. That's a very low probability. We justified it by saying that that's so low, we don't really have to consider that as a possible outcome. But it is important that you always look at all the different things that can happen. Otherwise, you're going to be shocked when something weird happens. I didn't bring it up at all to anybody, and I had two students flip it on their edge, and they kind of looked around kind of like nervously, and, oh no, what do I do? And I just let them come up with their own solution. Did they want to count it as something? Did they want to flip it again? Most of the time they flipped it again, but it can happen. Okay. Then the other thing I want you to do, and so maybe you're saying that you're doing heads and tails, right? We get heads or tails. And I want you to come up with a guess to this. What is the probability? Actually, I don't even want to say probability, I'm sorry. I want to say, how many times are you going to get heads out of 100 flips? How many times are you going to get tails out of 100 flips? Take a guess. Take a hypothesis. Okay, that's what we do in science class. Why can't we do it in math class? There's no reason. Okay, so go ahead and do that. And at the very bottom, it's going to ask you to count up the total number of heads and the total number of tails. So go ahead and pause the video, do that flipping, and figure out what you get. If you're back, that means you've flipped some coins. That's good. I hope you have. And you got some total. And I'm going to urge you to think, what did you get? Okay, as totals, I saw a lot of, say, maybe 52 and 48. I saw that quite a bit. Now, if you're using a phone to do it, it may even out a little bit better. But we had some weird things happen, and I talked about it in class, that we had weird things happen. Like, number one, obviously the two students that had their coin land up on edge, that was a weird thing. They weren't sure what to do. We talked about it, okay? It's a possible outcome. If you're flipping something that isn't always going to land one way or another, then that's another possible outcome. And so you should take a hypothesis for how often you think that's going to happen. Trying to back up a little bit. Another thing that people thought was weird, kind of, was, I phrased it as being weird. You probably expected to get 50 heads and 50 tails. because we always think of a coin flip as being 50-50. But for some reason, we didn't get 50 heads and 50 tails. Now, why is that? We pretty much justified it as saying it's a random chance, right? Another thing people found weird was they might have had a string of, I had people that flipped 8 tails in a row. That shouldn't really happen, but it can, because every time you flip the coin, it's a random chance. The coin doesn't know what it flipped last time. And that's why I say if you're going to use a phone to do it, it might kind of factor that in. It shouldn't, but it might. I don't know. But it's something that can happen. You can end up getting long strings of the same result over and over, even though there's only theoretically 2 results that you can get. You can get the same one over and over again. And it's only through a very long, repeated experiment like this that we start to see it trending towards what we would expect. I had somebody ask me, couldn't we do this like, they said 25 times and then multiply those by 4 to get these numbers? And I said, sure, you could also do it one time and multiply it by 100 to get those numbers, but that would be some skewed data. If I flip a coin once and I get heads and I multiply that by 100, so I got 100 heads, it's probably not going to happen in 100 flips. Okay, obviously I went very far off to one side, right? 25 is a pretty good number. You could get some good data from that, but they weren't even, it wasn't that they were trying to get out of flipping a coin, but it's something to think about. If you shut down at 25, you're cutting down a lot of opportunities to get your number more towards the 50-50 that you think it should be. And it should. I mean, I had somebody in class get like 65 and 35 or something like that, which is very much skewed, but it can happen, right? Eventually, somebody could flip 100 heads in a row. Probably not going to happen, but it could, because every single time there's what we consider to be a 50-50 chance of getting either one. Now, in the ones that we used, or if you're using a nickel, there is that other possibility that can happen, that it can land on its edge. And the reason we still give the flipping a coin a 50-50 idea is that usually you're, like, say, betting with somebody, okay? Well, if it lands on its edge, which isn't going to happen very often, no matter what, but if it does, you're going to say, okay, we'll flip it again. So there's still a 50-50 shot, okay? And yes, is it? No, it's like 49.9 and 49.9. It's very close. And when it comes up with an inconsistency, like if you were flipping a coin and it landed up next to something and it didn't give you a heads or a tails, it was leaning on something, you said, well, that's not really fair, let's do it again. And that's a difference between trying to get a result of heads or tails and that sort of that betting battle back and forth. Is it going to be heads or tails? You pick. Okay, let's look at some definitions and then we'll get some problems. So some things that I talked about there that I just kind of glanced over, we kind of already went over them, but the possible outcomes, or the set of possible outcomes, is a list of all things that can happen. And even when we get into the flipping a nickel, let's say, where it can land on its edge and stay there, the idea is still that it being heads or tails is still even, and that middle ground is a true middle ground, and it's a very small portion. So we didn't so much stress about that. And I don't want us to stress about it. I want you to think that it could be a possibility. So it might make your set of possible outcomes, but understand that its probability is not going to be the same as the heads or the tails. Okay? Its probability is going to be a lot less. An event is is a simulation of random chance. The idea that we had was flipping a coin is an event, random chance. An experiment is just a collection of events. Okay, our experiment was doing that 100 times. Okay, for probability, the definition of probability is pretty loaded in that there's a lot of things that you kind of have to talk about. And we're only looking at a couple things today. We're going to continue to build on that definition as we go. But probability is just the likelihood of an event occurring. And I think there's 2 R's in that, but I'm not sure. Okay, so the likelihood of an event occurring. Now, really an event is not just a simulation, but it's also included in the result. Okay, it's the result of a random chance experiment, I should say. And an experiment would be any number of things happening. Okay, but the likelihood of an event occurring is the probability. And we're usually going to see that in one of 3 ways. We're going to see it as a percentage. We're going to see it as a percentage. We're going to see it as a fraction or a decimal. Okay, 3 different ways that we could see it. Percentage is very common to talk about in mainstream media and a lot of different things. Sadly, we don't really talk in percentages for the simple reason that if you roll a die, if you roll a 6-sided number cube, you're going to get the numbers 1 through 6. Okay, not to get too far ahead. But if you're saying, what is the probability, and people confuse probability with odds a lot. We're not saying what are the odds of getting something. We're saying what is the probability. There's a big difference, but not in like common language, which is kind of sad because it gets confusing because people say, well, what are the odds that this happens? Odds are quite a bit different. It's related, but it's different. So if we're going to roll a 6-sided number cube, roll a die. A die is a singular word for dice. Rolling one of them. And we want to see what is the probability of getting 6. Well, there's 1 6 out of 6 possible. So the probability is going to be 1 divided by 6, and I'll talk about why in a second. The reason I don't really like percentages or decimals is 1 divided by 6 is like 0.166666 repeating forever. Okay? That becomes a pain to write and to do operations with, adding, multiplying, those kind of things. I'm going to prefer fractions. Okay? And I'm going to get you to prefer them as well, even if it hurts. And then probability has 2 kind of branches that it even lives in. There is what we call experimental probability. And there's theoretical probability. Experimental probability is what you see happen. So we just did an experiment that found some experimental probabilities. The example that I used is the probability of heads ended up being 52 over 100, which sure that reduces to 26 over 50 and 13 over 25. Okay. So that was the experimental probability because that's what I saw happen. And so that can always be different. Theoretical probability is sort of an idea of what should happen. And it comes from the probability of an event, comes from what I consider to be the number of wins, okay, a way to win the event over the total outcomes. And that more aligns to the idea of in a fair game, in a balanced game, you're not using a loaded die, where one side's heavier, so it wants to fall a certain way. Or even in the coin flip idea, if you're flipping a nickel, sure, it could land on its edge, but that probability is not equal to, that's not going to happen as much as a true heads or true tails. Okay? So, in a lot of times, those little minor things in theoretical probability, we are going to have to kind of skip those in a way, or save just a little tiny piece of the probability pie for those weird things to happen. Okay? If we're flipping a coin and we want to know the probability of it coming up heads, and if we assume that it's either going to land heads or tails, there's one win, that's the heads. There's two outcomes, heads and tails. Okay? So in theoretical probability, things have to be balanced. Okay? Otherwise, it doesn't quite work out too well. Okay? So let's look at some examples and try to get an idea of this. The first three problems, we want to find the number of possible outcomes for each event. So the possible outcomes for rolling a die, you don't have to necessarily write what they are. It's just asking for how many there are. But we have 1, 2, 3, 4, 5, and 6. So there's 6 possible outcomes. For picking a day of the week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, there's 7 possible outcomes. Flipping a coin twice is where it gets a little bit weird. And for this, sometimes in the past, you've probably used what we call a tree diagram to figure it out. If I flip a coin the first time, it's either going to land heads or tails. Again, we have to be balanced. From that heads, and I flip again, it's either going to land heads or tails. Again, the coin doesn't know what it came up with on the first flip. On the second one, it's going to either land heads or tails. If the first one came up tails, the second one could be heads or tails. So our possible outcomes come from the ends of these branches and how we get there. How did I get to this? I flipped heads and then heads. So the set of possible outcomes includes heads, heads. This one was heads and then tails. This one was tails and then heads. And the last one was tails and tails. I'm going to try to sneak that in there. So there's 4 possible outcomes for flipping a coin twice. Next, we want to find the probability. And now when I'm asking for probability in something that we haven't done yet, I'm really talking about the theoretical probability. What should happen? I want to look at the number of wins over the total outcomes, the number of total outcomes. If I want to know the probability of rolling a 3, so the probability of rolling a 3 is going to be, there's 1 3, and there's 6 possible outcomes. So 1 over 6. Again, you could write that as a decimal, but it's ugly. You could write it as a percentage, but the percentage is based on the decimal, so it's ugly also. 1/6 is a lot cleaner way to write that. The next one asks for rolling a number that's not a 5. So not 5. How many things are there that aren't 5? There's 1, there's 2, there's 3, there's 4, and there's 6. There's 5 things that aren't 5 and 6 total things. So this probability is higher than this. If somebody said You know, somebody said, roll a 3 or roll a number that's not a 5. Pick one of the two. You would want to say, I want to roll a number that's not a 5. My chances are higher. Getting heads on a coin toss. So the probability of heads, we kind of talked about this one already. There's 2 possible outcomes. One of them's heads, one of them's tails. So our theoretical probability is 1/2. Try to continue that same idea on these ones down here. There's somewhere I'm asking you for the number of possible outcomes, and you don't have to write them all out. You just have to tell me how many there are. Some of it's going to take a little bit of work. Randomly selecting a student in a room, that might be tough if you're in a different room, so do your best. There might only be one student in your room, and it might just be you. Anyways, get those done. If you have any questions, be sure to let me know. I'll see what I can do to help. Otherwise, I hope you have a great day, and we will see you in class.